The Z-20T is a specialized assault variant derived from the Z-20 medium-lift helicopter platform, which itself was developed to fulfill a long-standing requirement within the People's Liberation Army for a modern, domestically produced helicopter in the 10-ton class. The public confirmation of its entry into active service with Army aviation units occurred through official military media channels and public displays in the 2024 to 2025 timeframe, marking the operational maturity of this new asset. Its development signifies a deliberate move to expand the functional envelope of the foundational Z-20 airframe beyond its original utility and transport roles into a dedicated armed assault platform, thereby creating a new category of aircraft within the PLA's rotary wing inventory that combines the troop-carrying capacity of a transport with the organic, sustained firepower typically associated with an escorting attack helicopter. The airframe of the Z-20T is directly evolved from the base Z-20 transport model, retaining its overall dimensions and fundamental layout, which is a conventional single-main rotor and single-tail rotor configuration. The primary structure incorporates extensive use of composite materials in the fuselage and rotor blades to achieve an optimal balance between structural strength, overall weight, and damage tolerance. The 5-blade main rotor system is a critical design feature, providing significant advantages in terms of lift efficiency, disc loading, and acoustic signature reduction compared to older 4-blade systems. The additional blade allows for a slower rotational speed for the same lift, which reduces vibration and noise, factors that are crucial for both crew fatigue and tactical surprise during low-altitude ingress. The tail rotor is a 4-blade design that is canted at a specific angle, which serves a dual purpose, providing the necessary anti-torque control and contributing a small but measurable amount of vertical lift, which improves the overall efficiency of the aircraft. A fundamental engineering requirement for the platform, inherited and further refined in the T variant, is its capability to operate in all weather conditions, which is enabled by a comprehensive anti-icing system. This system protects the leading edges of the main and tail rotors, the engine intakes, and critical sensors from ice accumulation, a vital feature for conducting operations in high-altitude environments like the Tibetan Plateau, in cold climates, or through meteorological conditions involving freezing rain and supercooled water droplets. The propulsion system consists of 2 high-power turboshaft engines, identified in numerous analyses as the domestically developed WZ-10 model. These engines are the result of significant investment in aerospace propulsion technology and are designed to deliver a high power-to-weight ratio, which is the cornerstone of the helicopter's performance. This surplus power is essential for several demanding aspects of its mission profile. It allows the Z-20T to take off and land at high altitudes where the air is thin, to hover out of ground effect with a significant payload, to execute aggressive maneuvers while evading threats, and to maintain flight safety even in the event of a single engine failure. The main transmission, which transfers power from the engines to the rotors, is engineered to be robust and reliable, capable of handling the full power output of both engines and the high inertial loads experienced during maneuvers and auto-rotation. The technological core of the Z-20T is its integrated avionics architecture and flight control system. The helicopter is equipped with a digital fly-by-wire control system, which replaces traditional mechanical linkages with electronic signal transmission. In this system, the pilot's inputs from the controls are interpreted by flight computers, which then command the actuators on the rotors and flight surfaces. This architecture provides several key benefits. It can be programmed to provide inherent flight stability, automatically damping out turbulence and preventing the pilot from inadvertently exceeding the aircraft's safe flight envelope. It significantly reduces the physical workload on the pilots, especially during long, low-level flights, and it allows for flight control laws to be optimized for different phases of flight, such as a very stable hover mode for weapon deployment or a more responsive mode for nap of the earth flying. The cockpit is a glass cockpit, meaning it uses large, multi-function digital displays to present flight, navigation, systems, and tactical information to the crew, replacing the vast array of individual analog gauges found in older generation aircraft. These displays are reconfigurable, allowing the pilots to prioritize the most critical information for a given mission phase. For situational awareness and mission execution, the Z-20T is equipped with a sophisticated suite of sensors. This suite is understood to include a multi-mode radar, typically mounted in the nose, which can perform several functions including terrain following and terrain avoidance for low-altitude flight in poor visibility, ground mapping, and weather detection. A key sensor is the electro-optical system, housed in a spherical turret usually located below the nose. This system contains a thermal imager for night operations and poor visibility, a daylight camera, and often a laser rangefinder and designator for guiding precision munitions. To enhance its survivability in a contested environment, the helicopter is fitted with a defensive aids system. This integrated system typically comprises a radar warning receiver to detect when the aircraft is being illuminated by enemy fire control or acquisition radar, a laser warning receiver to alert the crew to laser designation, and a missile approach warner to detect incoming heat-seeking or radar-guided missiles. This information is processed by a central computer that can automatically or semi-automatically trigger countermeasures dispensers, which release chaff to decoy radar-guided missiles and flares to decoy infrared-guided missiles. The primary operational role that defines the Z-20T is that of an armed assault helicopter. Its fundamental purpose is to transport an infantry squad, typically up to a fully equipped section, directly into a combat zone, while possessing the integrated and substantial firepower necessary to suppress enemy forces and neutralize threats during the flight to the objective, the landing, and the subsequent extraction. This capability fills an operational niche that was previously addressed either by using pure transport helicopters that required separate armed escorts, or by dedicating attack helicopters to a support role that limited their own offensive potential. The Z-20T allows a single platform to penetrate a medium threat area and fight its way in and out if necessary. The armament is carried on two stub wings, which are short, fixed wings attached to the sides of the fuselage. These wings are structurally reinforced to handle the weight and stress of weapons in their pylons. They feature multiple hardpoints, allowing for a modular and configurable weapons loadout tailored to the specific mission requirements. Confirmed and observed armaments include advanced guided anti-tank missiles, which are fire-and-forget or semi-active laser homing missiles designed to destroy main battle tanks and other armored vehicles, unguided rocket pods, which provide a high-volume area suppression capability against infantry positions, light vehicles, and unhardened structures, and modern air-to-air missiles, which are short-range infrared-guided missiles providing self-defense capability against other helicopters, low-flying unmanned aerial vehicles, and slow-moving fixed-wing aircraft. The Z-20T is a single manifestation of a broader, strategically planned family of systems approach centered on the common Z-20 platform. This approach maximizes research and development investment by creating a common core of airframe, dynamic components, engines, and avionics architecture, from which multiple specialized variants can be developed. Another critical variant is the Z-20J, the naval version designed for shipboard operations aboard destroyers, frigates, and amphibious assault ships. The Z-20J incorporates specific modifications for the maritime environment, including a main rotor head and tail boom that fold manually or hydraulically to drastically reduce its storage footprint within the confined space of a ship's hangar, reinforced landing gear with a deck lock system that secures the helicopter to the flight deck to prevent movement in heavy seas, and extensive use of corrosion-resistant materials and coatings throughout its structure and systems to withstand the highly corrosive saltwater environment. The mission set for the Z-20J is distinct, focusing on anti-submarine warfare, for which it would be equipped with sonobuoy launchers, a dipping sonar, and lightweight torpedoes, anti-surface warfare surveillance and targeting, search and rescue, and vertical replenishment. From a perspective of future warfare and operational doctrine, the significance of the Z-20 platform, including the T variant, lies in its inherent modularity, its advanced digital backbone, and its capacity for network-centric warfare. The high degree of commonality across variants simplifies training for pilots and maintenance crews, streamlines the supply chain for spare parts, and reduces the overall lifecycle cost. The open systems architecture of its avionics and mission computers is designed to accommodate future technology insertions and specialized mission kits, making the airframe a potential candidate for roles such as an electronic warfare platform to jam enemy communications and radar, a signals intelligence collector, or an airborne command and control node. Perhaps most importantly, the Z-20T is designed to function not as an isolated platform, but as an integrated node within a larger networked battlefield. Through secure data links, it can share real-time sensor data with ground forces, other aircraft, and command centers, and in turn receive targeting information and situational updates from unmanned aerial systems and other assets. This network integration acts as a force multiplier, dramatically enhancing the situational awareness, coordination, and overall lethality of the combined arms formation, allowing the Z-20T to operate as a key component in complex, multi-domain operations that characterize modern military strategy.